All right, so we're going to go ahead and run through an example here of how to use the travel time curve. Let's say that I have a seismogram here, and this seismogram shows that there's a 3-minute gap between the first P wave and the first S wave. Depending on what practice problem you're working on, yours might look a little bit different. So if you're working on the scenario that has the earthquake where you're the representative from the United States Geological Service, the USGS, and you get woken up in the middle of the night because of an earthquake, then yours is actually going to have the measurement in seconds. Now, to know the amount of time between the first P wave and the first S wave, you have to look at the number of seconds at the first S wave. So it always starts at 0 and then moves into number of seconds. But if you're using one of the practice problems, the other practice problems we did, it will have the measurement in minutes. Okay. So we're going to look at two examples. We're going to look at how to do this using the normal travel time curve, which I have right here, and then also using the travel time curve, which you may be referencing in your homework, where you have a straight line that goes up like that. All right, so let's do the normal travel time curve first. So let's say that I have a 3-minute gap between my first P wave and my first S wave, as outlined right here. So what I'm going to do is I'm going to line up my piece of paper in the corner, and I want the paper to be flush at the origin and be totally parallel here with the travel time axis. Okay, so I'm going to mark it at 0. And I'm going to mark it again at the 3-minute mark, because that's the amount of time that I have between my first P wave and my first S wave. Now what I'm going to do is I'm going to move this piece of paper over, and my goal is for this bottom mark to hit the bottom line, which is the P curve, and then the top mark to hit the top line, which is the S curve. So I'm going to keep going, keep going, keep going. Okay, so here I've clearly gone way too far, because even though this bottom mark is touching the bottom line, the top mark is actually below the top line. So I'm going to move back over this way. And it looks like I'm right at home here at about 1.8. So remember that each of these thin marks is 0.2. So I'm going to say this is 1.2, 1.4, 1.6, 1.8. So right here where my lines kind of seem to sync up is at 1.8. All right. Now remember that 1.8 is not the final answer. 1.8 is actually in scientific notation on this travel time curve. So the actual number is 1.8 times 10 to the third. Now, in order to get 1.8 times 10 to the third, actually this is 10 times 10 to the third kilometers, in order to get that into a real number, what I've got to do is I've got to move this decimal place to the right 3 spots. So here's what it would look like. So it would be 1.8, 1, 2, 3. So what I'm going to do is I'm going to add zeros here, and then because I moved 3 spots, I move my decimal back there. And because I'm still using the same unit of measurement, I'm going to stick with kilometers. So my final answer in this example is going to be 1,800 kilometers. Now, if you're doing the homework where you are in the United States Geological Service, this is the homework packet that you may have gotten in class. Here's what you would do. There's only one line here, and it says something like S minus P or P minus S. I can't remember which one it is. But what you're looking at here is just one line, which means you don't need to use a scrap piece of paper. You can just follow the line up. So let's say we're doing the same example here. Okay. Let's say that we were looking at 3 minutes again. Okay. So what you would do is you would actually, oh, I do my 3 backwards here. Is that right? Yeah, looks good. Okay, so let's say that I am trying to find 3 minutes. What I would do is I would move up the y-axis until I got to 3. And then I would move over until I intersected with the line. There's no need for scrap paper, I just need to intersect with the line. Okay. Once I've intersected with the line, I'm going to go back down towards the y-axis, the x-axis, and that's going to give me my answer right here. So whatever number it is, in this case it would be 1,800 kilometers again, that would be the answer that you want. So this is actually a lot easier than the normal travel time curve that we're going to be using. But I think this one better illustrates the idea that the further away you get from the origin, the more time there is between the P wave and the S wave. Hope that helps. Email me if you have any more questions.